Hi, it's me, Dr. Prasad Puthiyillam. Continue my classes on YouTube channel, My Intuition. This class is for Haloarenes. My YouTube channel, My Intuition, offers regular and coaching classes on chemistry and learning mathematics. This is class number 11 of Haloalkanes chapter, the reactions of haloarenes, nucleophilic substitution reactions. Haloarenes or aryl halides are extremely less reactive towards nucleophilic substitution reaction. There are mainly four reasons for that: resonance effect, sp2 hybrid carbon, instability of phenyl cation, possible repulsion by electron-rich arenes. We'll see one by one. Resonance effect. So haloalkanes or haloarenes, not haloalkanes, haloarenes. Say example chlorobenzene. It has chlorine has got a lone pair of electron. Because of that, this lone pair of electron can try to form a double bond with the carbon on the benzene ring. Okay, so electron movement, electron shift takes place, so that this double bond will split to the corner. The ortho carbon will get the electron density. Okay, so it can be represented like this with a double bond here and a negative charge on the ortho position. Now this electron density can further move, forming a double bond here, and this second double bond, it will split to the para carbon, giving electron density at para position. So it is represented like this. Further electron movement is possible like this, and the electron shift takes place to the carbon. Again, it is an ortho carbon. Okay, therefore we can say that these structures, canonical structure or resonance stabilizing structures, contributes towards the total effective shape or size of the uh, shape or the structure of the chlorobenzene, in which we can say that the carbon chlorine has got a partial double bond nature. Okay, it is not a single bond itself, it even has got a double bond nature. Okay, so CCl bond acquires partial double bond character. Because of that, the chlorine CCl bond is, it's not so easy to break, so that substitution reaction takes place easily. So it is not as easy as that of alkyl halides. Haloarenes are not as much easy towards electrophilic substitution reaction, nucleophilic substitution reactions. The second reason, that is sp2 hybrid carbon. Sp2 hybrid carbon in alkyl halides, the carbon connected to the chlorine. This is an alkyl halide, not a haloarene. So in alkyl halide, the carbon connected to the halogen atom, that carbon is sp3 hybrid carbon atom. Whereas in haloarene, say chlorobenzene, the carbon connected to the chlorine, that particular carbon, it is, or it is sp2 hybrid carbon. All carbon in benzene ring are sp2 hybrid carbon. So because of this sp3 hybrid carbon, the CCl bond in alkyl halide is around 177 picometer. In our chlorobenzene, it is 169 picometer. That means in case of sp2 hybrid carbon, it has got more s character. Okay, so only 2p and 1s, whereas sp3 means 3p and 1s. So in haloarenes, the carbon containing connected to the chlorine, it has got more s character. More s character means it is the atoms are near to the nucleus. The element which is connected to that carbon will be near to the nucleus. Therefore, it's a strong bond, and it affects the bond length. It becomes 169 picometer. Therefore, due to the sp2 hybrid carbon in haloarenes, they are also less reactive towards nucleophilic substitution reaction. Instability of phenyl cation. So you know the nucleophilic substitution reaction, one of the intermediate in SN1 reaction is the formation of a carbocation. So if carbocation is stable, then the nucleophilic substitution reaction continues, you'll get the product. So if such type, if the halogen atom is removed from benzene, then the particular carbon will get a positive charge. We call it as phenyl cation. So phenyl cation, it is less stable. There is no resonance structures which contributes towards the stability of this structure. Therefore, we can say that with the phenyl cation, by seeing the structure of phenyl cation, we can say that haloarenes will not undergo SN1 mechanism as such. It is ruled out. The possible repulsion by electron-rich arenes. Okay, so benzene ring, it has got electron-rich center. So this entire carbon atom, it has got electron density. The electron pi electron movement is there. Therefore, there is a total electron rich center. It is an electron rich center that total electrons are there. Therefore, a nucleophile cannot attack or cannot come and join to the carbon easily. So, nucleophilic substitution reaction, where nucleophile is also having negative charge, the arenes are having high electron density. Therefore, as such, there will be a possibility of a repulsion. Okay, but still at higher drastic conditions, haloarenes undergo replacement reactions. So replacement hydroxyl group example is given. Say chlorobenzene gives corresponding phenol. Okay, that reaction conditions are very drastic. At with aqueous sodium hydroxide at a very high temperature of 623 Kelvin and high pressure 300 atmosphere, followed by protonation, will get the product. If the molecule is the chlorobenzene has got a substitution, the nitro substitution at para position, then the corresponding alcohol formed, the conditions are little bit less drastic compared to the reaction of chlorobenzene as such. Okay, only 443 Kelvin with aqueous surge followed by protonation will get the product. If the nitro group substitution is more, even if the ortho position also NO2 is there, so dinitro. Okay, two nitro NO2 groups are substituted to chlorobenzene. Then further the reaction conditions required to get the corresponding alcohol is decreasing. Okay, so it becomes 368 Kelvin followed by protonation. So we'll get the product. If it is tri-substitution, NO2 on all ortho and para positions, then just by adding to hot water or just by warming, we will get the corresponding product. That means this NO2 has got some effect to contribute. Okay, so see, NO2 is an electron withdrawing group only at ortho and para positions, not at meta position. Therefore, if substitution NO2 substitution or NO2 group is there at ortho and para positions, it will support the reaction. Okay, that nucleophilic substitution reaction, it will support. Say, nucleophilic substitution reaction takes place in which the hydroxyl group is connecting to the carbon containing the chlorine. Okay, when group is connected there, so when a group hydroxyl group connects here, this double bond from here it will shift there. Okay, so I'll take the pen option. Okay, so double bond was there, it will splits and forms an electrodensity there. Therefore, if an NO2 group comes, this nitrogen having positive charge and here the negative charge, so this electron density it can take. Okay, so that electron density at that ortho position it can take, so that this chlorine can go easily, and the NO2 group is contributing towards the resonance stabilization. Okay, so at ortho position, whether this is ortho position, this is also ortho position, because the next movement will be here, this electron will be shifting here. Okay, that means here the electron moved here, which then moved further here, then the double bond breaks to the corner, we are getting a negative charge at a para position also. So even if the nitro group is at a para position, that NO2 group, that also will contribute towards the pulling out that electron density, so that this bond becomes strong and further the chlorine can go out. Okay, so this is the nucleophilic substitution, how the NO2 group is contributing. Whereas at meta position, so this is the meta position. At meta position, there is no possibility of getting electron density. Therefore, if NO2 group is there also, say NO2, NO2, even if NO group is there also, it has got no effect as such on the resonance stabilization. Therefore, the effect is more at ortho and para position, not at meta position. Okay, so thank you very much for watching my video. Please do subscribe my YouTube channel. All the classes related to chemistry and the entrance training classes are I'm uploading to my YouTube channel. Thank you very much. I'll sign out from the presentation. Once again, thank you very much and have a nice day.